Alright, on the next couple of questions we have basically a half-life question, and we're going to use, anytime you're talking about half-life, we're using the PERT model because it's a continuous exponential decay that we're talking about. So on this question, the lead-in is Gordon, some guy Gordon, whoever that is, has a limited edition silver crowbar made from silver 111, some isotope of silver that's highly unstable because it has a half-life of just over a week, 7.45 days. Crazy. Brand new, the crowbar has a mass of 6 kilograms. Okay, so find the daily rate of decay. So the daily rate of decay is based on this thing called half-life. What half-life is if I have this unstable material, it's the amount of time that it takes for the material to decay to half the amount that you originally had. If I had 6 kilograms, then in 7.45 days, I'm going to end up with 3 kilograms. Okay? So we're just going to set that up in this equation where P is the original amount. It's like the principal whenever we're talking about money, which is 6 kilograms, and Y is what we're going to end up with, which is 3. So 3 is equal to 6 times E raised to the RT power. I don't know what R is. I'm trying to solve for R, but we know the time is 7.45 days. So 7.45 to the T power. Okay, I have to divide by the 6. I have to isolate the exponential term before I can take the log of both sides. So whenever I divide by 6, I'm going to get a half on the other side. Half-life. See, it's equal to a half. E to the 7.45t. Since this is base E, it makes most sense to just take the natural log of both sides. So on the left-hand side, I have the natural log of a half is equal to, and then the E will just cancel because natural log and E, they're inverses of each other, and I'm just left with the exponent 7.45t. And then finally, to get our T, the amount of time, not T, this is not T, what am I doing? It's R. It is R. Let me go back and switch all these T's. Not that it makes that much difference, but we're solving for R, not for T, because we knew what R is. So to get R, we divide by 7.45. Natural log of a half divided by 7.45, and when you put it into the calculator, we get about negative 0.0930, and this is a number that you should store in the calculator. Story, that's brilliant. I want to store that into the calculator. That way I don't have to keep typing it, and I can get an accurate decimal here. I'm sure if you were doing this in a chemistry setting, some sort of science setting, you'd have to use significant digits. In that case, it would only be 1 because you're talking about 6 kilograms. But anyway, we're just going to go ahead and use that whole digit that we have. And if we're talking about a daily rate of decay, maybe I write that as an actual percentage. In that case, it is going down by 9.3%, and that's per day. Right? Okay. So on the next couple of questions, we're going to use that daily rate of decay to write an equation and then find out how much is left after a certain number of days or whatever. Okay, so on number 24, write an exponential decay function for the amount of Y of silver left in Gordon's crowbar. So we started off with 6 kilograms. E to the, and we found the rate, and the rate was negative 0.093. Right, let me just double check that. Maybe I put an extra 0 at the end of it, but I don't need to. Times x, where x is the number of days. Okay, so this one is finished, and we're going to use that equation that we just came up with on number 24 on number 25. So in how many days does your model from question 24 predict the mass of the crowbar to be 1 gram? And I underlined gram here because our original amount was in kilograms. Well, 6 kilograms. How many grams are there in a kilogram? There is K. There are K of them. K of them is 1,000. So this is equal to 6,000 grams. And so it's more sensible to just change this number of 6 that's inside the equation to 6,000. So then we're all in grams now. So y is equal to 6,000 grams e to the negative 0.093x. And again, this is a number that I have stored in my calculator, so I'm using a more accurate decimal. Now I'm going to take the y out, and I'm going to put a 1 in its place. I want to be left with 1 gram. So divide by the 6,000, it's 1 over 6,000 is equal to e to the negative 0.093x power. And then take the natural log of both sides of this. Natural log, of course, because it's the inverse of e. So I have the natural log of 1 over 6,000 is equal to, and the e will cancel out with the natural log, inverses again, equals negative 0.093x. And then finally, to get the x, we divide by the negative 0.093. So x is equal to the natural log of 1 over 6,000, in parentheses there, all divided by negative 0.093. Putting this into the calculator, we get approximately 93, wait a minute, here we go, 93.5 days. Hey, that's not too bad. 93.5 days, and I have 1 gram of my original crowbar left. Okay, there we go. Now, then this one's done.